Okay, so for multiplying numbers written in scientific notation, there is something that we need to understand about the way that exponents work. And so what we're going to do is, before we get into the actual problems, I'm just going to do a couple quick examples of how to demonstrate this. And so let's say that we had 1,000 times 1 million. Well, most people would not do the long multiplication of all of this. They would just recognize that, oh, I just need to basically put the total number of zeros with a 1 in front of it. And so I have 3 zeros on 1,000. I have 6 zeros on 1 million. So I would need 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I was to write those numbers in scientific notation, 1,000 would be 1 times 10 to the power of 3. And 1 million would be 1 times 10 to the power of 6. You'll notice that when we did it just by counting zeros in the beginning, we ended up with 3, 6, 9 zeros. And what I'm hoping that you're able to see is that the exponent 3 and the exponent 6, if I was to add those two exponents, 3 plus 6 makes 9. So this would be the same as 1 times 10 to the 9th. And so when we're multiplying numbers in scientific notation, what we need to do basically is just look at the exponent that's on the 10 and then add those two exponents up. That's going to be the exponent that goes on our final answer. We'll do one more example of that. Let's say I have 3,000 times 25 billion. So what we would end up doing is saying 3 times 25 is 75. And then we would count our total number of zeros, and that's how many zeros we would have. So in this case, that would be 12. And we would end up with 75 trillion. Now, similarly, doing that with scientific notation, we would have 3 times 10 to the power of 3 times 25 times 10 to the power of 9. And what we would end up doing in this instance is we would just multiply the whole number piece. So 3 times 25 is 75. And then we add the exponent that is on the 10. So the 3 plus the 9 is going to make 12. And that basically tells us that we have a 75 with 12 zeros after it. Okay, on to the problems in ALEKS. We have 3 times 10 to the 4th times 2.3 times 10 to the 3rd. And so what we're going to have is the 3 times the 2.3 is going to make 6.9. Then we just look and say, okay, that 3 would have 4 zeros on it. The 2.3 would have 3 zeros on it. The 4 zeros plus the 3 zeros makes 7 zeros. So 10 to the 7th. And the way to put that in, we've got to click this tool here. And we get 6.9 times 10. Just click over into that spot, 10 to the 7th. Okay. And next we have 3.2 times 10 to the 9th times 2 times 10 to the 3rd. And so 3.2 times 2 is 6.4. And then 9 and 3 makes a total of 12. Again, we would have 9 zeros with the number on the left and 3 zeros with the number on the right, making a total of 12 zeros. Okay, one more. We're going to try something different than that. Okay, 7.2 times 10 to the 4th and 6 times 10 to the 8th. So 7.2 times 6 is going to be We're going to have to make an adjustment on this one a little bit, I can see. So 7.2 is going to be 42.2. No. Let me pull out my handy calculator here, okay? That's going to be 43 point, I think it's 43.2. 7.2 times 6, 43.2. 43.2 times 10 to the 12th. Now recognize that this number is not correctly written in scientific notation because we have two numbers in front of the decimal. So what we need to do in this instance is we need to fix that. And so we're going to take that decimal and move it one spot to the left. So it's going to become 4.32 times 10 to the 13th. Because we need to move the decimal one spot to the left to have only one whole number in front of the decimal. Okay, and I will try to find one more like that so that we can practice having to do that one more time. All right, this one will work for us. We have 5.4 times 10 to the 9th, 10 to the 2nd actually, and then 9 times 10 to the 5th. So 5.4 times 9, 48.6. We add the exponents on the 10, so 2 and 5 is going to make 7. And again, this number is not correctly written in scientific notation because we have more than one number in front of the decimal. So we do need to scoot the decimal one place to the left, which is going to make that 4.86 times 10. We need one more decimal place, so 10 to the 8th. So 4.86, 10 to the 8th. Okay, that's it for this section.